Hello friends. So let's talk about the energy diagram today. Uh, we already know that kinetic energy plus potential energy is the total mechanical energy. So from here we can write that kinetic energy is equal to E minus U, and from this relation we can clearly write that U greater than E not possible. Why? Because if it is the possibility, then under such circumstances kinetic energy will be negative, which is practically impossible. So on the basis of that we will analyze the diagram which is called energy diagram. So let us imagine that this is a U versus R graph. This is U versus R graph. So here I am taking a random curve like this one curve I am taking, and we have two lines like this is total mechanical energy 1, and we are taking another graph like this is total mechanical energy 2, and we can take another graph like this is total mechanical energy E3. So initially we will assume that a particle is at this location, which is, let us say, at position x0. So when a particle is at here, if I analyze this position, so we can write that at x0, if you check that, we know that force acting is equal to minus of du dr. The slope here at position is coming to be 0. So x0, this point is a position, equilibrium position. But we are not sure about the nature of the equilibrium, whether it is a stable equilibrium, unstable equilibrium, or neutral equilibrium. We are not sure about that. That we will check. How to check? So if we disturb the particle a little bit on the leftward direction, if you check on the leftward direction, the particle is little bit disturbed, and we are now analyzing for total energy E1. So if it is disturbed leftward, then from this relationship you can check that we have already written that mod of f is equal to du dr. Eliminating the negative sign here, we have taken the mod. So the slope is increasing on the leftward direction. So slope is increasing. So the magnitude of the force is increasing as you move leftward. So when the particle is proceeding leftward, mod of f, this value is increasing. Let us look at the graph again. So particle is moving leftward, slope is increasing, magnitude of the force is the slope, so magnitude of the force is increasing. But if we write in the vector equation, we know that is equal to minus of du dr r cap. So what this minus sign suggests is that the force acting on the particle will be opposite to the direction of the increasing slope. So when the particle is disturbed leftward, force will act rightward direction. In such case, the particle will be able to go maximum up to this position. So let us say this is x1. The particle can maximum go up to x1. Why it can go up to maximum x1? Because if you check the region beyond x1, see this is E1 value. So beyond x1, in this region you can check u, in this region u is coming to be greater than E1. So u greater than E1 is not a possibility. So we can write that at x1 particle will turn back. Now that is also very interesting. Why the particle will turn back? See, at x1, if you check here in the graph at x1, velocity of the particle is 0. At x1, velocity of the particle is 0. So we can write that at x1, velocity of the particle is 0, but force is not 0. Why? Because slope value is not 0. So velocity 0, force non-zero, that means acceleration also non-zero. So from x1, after stopping here, the particle will turn back and it will start moving in the rightward direction. Initially, when it was moving leftward, force was acting rightward, so velocity was decreasing. Now, coming from x1 to x0, in this direction, force is acting, so velocity is increasing. So it will cross x0 position. It will cross x0 with some finite velocity. Then it will again start moving in the rightward direction. So while it is moving rightward, so now x0 to it is moving rightward. So from x0 when it is moving rightward, let us check. So in rightward direction when it is moving, same situation, slope is increasing, so force will act towards this x0 position. So up to maximum what distance can it go? Up to this, because in this region again u is greater than coming to be e1, so particle cannot exist because kinetic energy will be negative. So it can maximum go up to x2. So again at x2 it will stop, velocity 0, acceleration non-zero, so it will turn back, right? So again I will write that at x2 it stops and turns back. So that means if you look at the diagram, if we disturb the particle a little bit from the point of x0, it is basically executing SHM about x0 and to extreme x1 and x2, right? So the particle is showing the tendency to come back again and again. So x0, this point x0, we will write that x0 is the position of stable equilibrium. So what can we say about the stable equilibrium? We can say that whenever a particle is disturbed from the equilibrium position and it shows the tendency to come back to that position again and again, then this point x0 becomes the position of stable equilibrium. And from there we can have few more information like this point x1 and x2 from where the particle were turning back are called turning points. And one more important thing, if you check at the diagram, this is looking like a valley, which is often called as potential valley. So whenever a particle is trapped in potential valley, it will be in stable equilibrium.